Hi, I am Sungbok Shin. I am the presenter of the project Data in Context, Bringing Data into Your World. In doing the work, I collaborated with Andrea and Dr. Niklas Elmqvist, who is my advisor. So, place or space plays a central role in how humans think. When people reflect on their most memorable moments, not only do they cherish the event, but they cherish thinking about the location the event took place. Also, our body gestures or small physical movements in the space can work as cues that convey meaning. For example, thinking about the future causes people to lean slightly forwards, whereas thinking about the past causes people to lean slightly backwards. In this work, we're focused on deepening the involvement of spatial influence in understanding context-aware information. Context-aware information refers to information that pertains to the location. In particular, we will closely examine ways in which immersive technology, whether AR, VR, or MR, can help the way humans take advantage of space for sense-making the related information, which we call situated visualization. For example, let's look at this diagram. Imagine you're wearing glasses that shows your estimated arrival time on top of the bus you're about to take, tells you the remaining capacity of seats, the price, and other sorts of information that you'll be interested in taking the bus. We believe that situated visualization will make our everyday lives more user-friendly and more effective by spreading out relevant information in situation. Situated visualizations can be beneficial to many application fields. While being an operation room, the situated visualization can help the operating processes of the surgeon by providing information which is relevant to the operation. Furthermore, surgeons do not need to look up for some kind of data they want to see during the operation. They just can look over in the visualization. Even in military operations, situated visualizations can be very helpful. Military sites are where rapid and flexible decisions must be made in a very short amount of time. Since many battlefields may not always be familiar to the military operators, acquiring adequate information of the situation is crucial. When choosing a place to live in, there are many things we need to consider. We would need to think about the crime rate, whether there is a school nearby, or how far is the shopping center away from the house. Also, we need to consider environmental factors such as the temperature or air pollution of the location. Instead of looking for each of the information separately, situated visualization can present all the related data in one view. This will fasten the decision-making processes of users. With this belief in mind, our team at the HCIL in UMD have surveyed the growing landscape of virtual, augmented, mixed reality where computer graphics is used to create situated visualizations. With the survey, we have designed a theoretical model for situated analytics. We will start off by providing 4 prerequisites of situated visualizations. What are the conditions for being a situated visualization? First, they have to be data-driven. They should represent data of some sort. Second, the data should be represented in the form of visual components, such as graphs, bars, and so on. Third, mobility. To be situated in different points of interest, you should be able to move around with the device. Lastly, location-based. The data that is appearing in the screen has to be relevant to the location you're in. With these 4 conditions for situated visualization, we collected 28 academic papers and commercial products that fall under the 4 conditions. Using them, we try to designate a design space that can wholly explicate all these visualizations. We came up with 4 design dimensions. They are integration, form factor, interaction mode, and navigation mode. Integration is about how are scenes blended with the real world? Is it displayed in a separate view, or is information displayed as an overlay? Form factor. Form factor is about what part of the body is used to manipulate the system. Is it handheld or is it hand-worn? Interaction mode talks about the medium in which the users interact with the device. How is user input added to the device? Is it on a touchpad, gestures, or voice? Finally, navigation mode talks about how the user navigates between different navigation. Is it by searching or by gazing on the machine? We also could identify several archetypes of situated visualizations that we would like to share with. First, heads-up displays are mainly used for exploratory purposes. They are used to provide informative explanation on top of users' fields of vision. Second, wayfinders or navigation aids are used to help people identify locations while being in place. Many tourist applications deploy navigating tools to provide users information about where they currently are. Third, embedded virtuality makes computer-generated objects look real. Last, embedded abstractions blend in the user's fields of vision to provide detailed information about a specific location. So far, we have talked mainly about what situated visualizations can do and how they're being used. However, in order for developers to create a more effective situated visualization, we should be aware of both the advantages and the disadvantages of situated visualization. So now, we provide a brief list of strengths and weaknesses that situated visualization possess. We assess the strengths and weaknesses in three aspects. They are field, technology, and visualization. When I talk about field aspects, it deals with issues that are affected by the field or being in situ. The strength is that situated visualizations thrive in situated settings. Suppose you want to purchase a chair and you want to see if it fits into your place. Then you can utilize situated visualizations to see how it looks. Also, being situated in a place, it helps recall both short and long-term memory when not being in space. However, one main weakness is that looking at situated visualizations, you might get distracted on the way and maybe become a little dangerous. Technology aspects refer to issues that rise because of technological issues. From technological perspective, situated visualizations work in heterogeneous environments, whether it is a handheld device or a hands-free device. However, on the other hand, some state-of-the-art AR products are still expensive, not being accessible to a large audience. For example, a HoloLens 2 costs $3,500, which is still burdensome for a general audience to purchase. Also, there are still areas where the technology is not perfect. One example would be location accuracy. Visualization aspects refer to issues that are related to visualization. The strength in terms of visualization aspect is that situated visualization is effective in embedding data in the real world. This provides benefits in activities such as accurate size estimation and wayfinding. On the other hand, as many of situated visualizations are 3D based, they share the disadvantages that 3D visualizations have, and these are occlusion, distortion, and navigation. So we have noted various advantages and disadvantages about situated visualization. However, many strengths and weaknesses discussed are not fully empirically proven. To provide an empirical ground to the strengths and weaknesses, and to understand the effect of being situated in a more close to detail, we designed an experiment. In doing the experiment, we developed an AR platform called Stalker. Stalker, as you see in the picture, is an exploratory visualization tool that represents special information that can be filtered based on their features with an embedded overview. In creating this interface, we used a Magic Leap headset. To sum up, situated visualization tools are gaining popularity in both research and in businesses. Motivated by this, we have surveyed the growing landscape of situated visualization and built a theoretical model of situated visualizations. We designated design dimensions, identified archetypes based on the patterns found in them. Furthermore, we analyzed the advantages and disadvantages of situated visualizations. For more information, please leave a message at my email noted here. Thank you.